Good morning, grade 9 class. Today is Friday, and it is again another snow day. Today we are going to be looking at cycle 3, day 2 and 3. So we're going to be skipping over day 1, and we're going to be looking at day 2 and 3. If you still need to complete your cycle 2 test, you can do that on Monday, as well as your cycle 2 task. Could you please complete that over the weekend and hand it in for Monday? We're going to be looking at cycle 3, so if you have those, go and grab them. If you don't, you can grab a piece of paper and sketch some things down on the paper. Again, today we're looking at day 2 and 3, skipping day 1, and just looking ahead, our next test will be on March 7th. All right, so let's go ahead and look at this. Anytime during this video, you can press pause, fast forward, rewind, whatever you like. Okay, so to start us off, we're going to be looking at some algebra tiles, and we will have these on Monday as well. So for us in class, we have red and blue, red being positive, blue being negative, but on the sheet of paper, we have the filled in one in green here would be positive, and then the one that's not filled in, so empty one would be negative. We have that for x squared. And why is it x squared? Because it's like x by x. And then we have these longer ones, which is considered x because it's like a 1 by x. And same with the negative, and we have our 1 by 1. All right, so let's get started. Use the above tiles to model each of the following areas. Okay, so we have 16 meters squared. We can see it's positive, so we're going to be working with the filled in ones, right? And it's really open-ended. So here we could have 16 little squares, would be 16 meters squared. So 16 of these. Hopefully you guessed it. You have to have these filled in, right? Because we are looking at 16 meters squared. It is a positive value, not negative. So these should all be filled in. So that's 16, 4 by 4, which is 16. Hey, we could also do that with one big square and just give the dimensions of 4 by 4. Or we could do it with these longer ones. And let's say the dimensions are, well, the dimension will always be 1 on the bottom. But let's say it's a dimension of 4 here. So this would be 4 by, well, 1, 2, 3, 4. So 4 by 4. So these are all 16 meters squared. 2 floor tiles of unknown area would just be, you get to pick any 2 floor tiles of unknown area. So there we go. Again, these ones being filled in because we're looking at something that's positive value, not negative. Raylan used tiles measuring 1 by 1 centimeters to make a square area of 9 centimeters squared. So the only ones we can use here are the little 1 by 1s. That are again filled in because we're not looking at a negative value. And lastly, we have 3 new houses have identical square foot yards of unknown area. So just 3 big blocks. We don't know what the area is, but we do know that it is positive. For your next task with a partner, if we were in class, you would discuss and write down some patterns that you see in the above images. Your patterns might be that these ones are big, the big squares are the x squares. You might see some patterns that there's the little 1 units, or the longer ones might all match, or these are all negative. We can even talk about that there's only 1 x squared here, 2 values of 1, so 1 plus 1 is 2. This would give us 1x plus 1x plus 1x is 3 x's. For our last unit, we did x times x times x, which would be x cubed. So you can see that there's a difference here. For this unit, for this cycle, we're looking at x plus x plus x, which gives us 3x. Last unit was x times x times x, which is x cubed. So we can see that there's a difference in those answers as we're adding or multiplying. Here we'd have negative 2x squared. There's 2 x's here. There's negative 3x and negative 3 here. All right. maybe some patterns. Maybe you see 3 here. There's 3 of them here. There's tons of patterns. There's really no right or wrong answer. All right, so we're going to write down some definitions here. If we were in class, I'd ask you to find them on your own, but I'm going to write them out here for you. So expanded expression is an expression that has no collected items. So for instance, you can have like an apple, and an apple. Here's my apples. Apple plus an apple plus an apple. Well, if we put them together, we would get 3 apples. But an expanded expression, they're not collected. So they're just separate. But a simplified expression has all the expressions are collected. So we have all these collected items. An expression that has all items collected. So if we wanted to look back at these apples, 1 apple plus 1 apple plus 1 apple is 3 apples. That would be collected or simplified expression. Right, next looking at a term. A term is a single number and or variable separated by a plus or minus. So for instance, for example, we can have 3x plus 2. This would be like 3 apples plus 2 oranges, if you wanted to put like another variable, sure. So this would be this would be a term right here. So this is a term, is a single number separated by a plus or a minus. So this would be a term. And then this would be a second term. So there would be 2 terms here. The coefficient is a number that is multiplied by the variable. So for instance, let's say we had something like 2x. The coefficient here is just the number in front. It's the big number in front. That's what the coefficient is. That's what we call a coefficient. Where 2 is a coefficient. And hopefully you guessed it, x would be the variable. So a variable is a symbol, usually a letter. Above I used apples. Standing for an unknown numerical value. So if we go back to this problem right here, the 2x, so 2 is our coefficient, x would be the variable. So in this case, the x is our variable. So our variable here would be x. Or above, it would be apples. All right, and then we have our constant term is a number without a variable. Or it could be a variable that has an exponent of 0, because a variable with an exponent of 0 is 1. All right. So for instance, we can have like 2x to the power of 0. This would just still equal to 2 times 1, which is equal to 2, so still being a constant term. So constant term has no variables on it, but it could have like this variable that is in disguise. It's a variable in disguise because it has a power of 0, which is equal to 1. All right, a monomial is an expression with only one term. We talked about terms above. So a term is a single number and or variable separated by a plus or a minus. So here we'd have two different terms. And if we only had like the 3x here, that would be our monomial. So separated, it's only one expression. So one expression, pick your favorite number. So for example, like 5x. There we go. That's one term. Or you can say something like 7y. It's only one term. There's no pluses or minuses. A binomial now, just like bicycle, bike has two wheels, is an expression. You guessed it, with two terms. So for instance, here we could have something like 3x plus 2 y. Something like this. What we can't have, so what it is not something like this, like 3x plus 2x. So it can't be this because this would be like 3 apples plus 2 apples, which actually gives us 5 apples. And 5 apples is a monomial. That's an expression with only one term because these can go together. And we're going to see more of this too. But these ones can't go together. 3x and 2y, this would be like 3 apples and 2 oranges. They don't mix. That means they are two separate terms. We can see that there's a term here, one term here, and one term here. So they're separated. Here we have two terms, but those can be combined to give us one term. So this would be actually a monomial, or this is a binomial. Lastly, we have what we call our trinomial. And hopefully you guess this one, trinomial or tricycle. And a tricycle has 3 wheels. So this is an expression with 3 terms. And again, they have to be all different. So the numbers can be the same. Like we could have like 3a plus 3b plus 3c. That's completely fine as long as the variables are not the same. So they're all different here. We don't have to have just pluses. We can have minuses too, like that. Right, and then lastly, a polynomial. These are actually all considered polynomials. A monomial, binomial, trinomial are all considered polynomials. They just have fancy names for them. And lastly, we have our polynomial. A polynomial is an expression with 4 plus terms. So for instance, you can have something like 5x plus 6y minus z plus 4. There we go, that's a polynomial. All right, so let's move on to task 3. Task 3 is talking about using algebra tiles to model the algebraic expression. So again, 7 would be we're back to those algebra tiles. So 1, 2, 3, 4, 5, 6, 7. And again, yes, they are filled in because it's a positive 7. If it was a negative 7, we would not have them filled in. 4x, so we need 4 x's. So there's 4 of the long ones. Again, filled in because it's positive. X plus 3. All right, that's 1x. See how there's just one single x. We also talked about how we can have a coefficient in front of the x being just 1. And then this would be plus 3 little squares, 3 little ones. And then 3x minus 2, so again we have 3 x's. 1, 2, 3. These are all filled in because they're positive, and 2 empty ones because it's negative.